Question number 7 given x is equal to sigma n equals 0 to infinity cos power 2n theta. Y the same pattern but sin power 2n theta. Z the same pattern but now cos power 2n theta into sin power 2n theta. How are we going to do this? Theta is between 0 to pi by 2. That is, we are in the first quadrant. We need to show x into y into z is x plus y plus z. We are going to use this formula because it is sigma. Certain summation formula we are using. 1 by 1 minus x. Whenever you have, we expand it. 1 plus x square plus x cube and so on. It goes up to infinity. Look at the very first expansion. Wherever n is coming, I have to put 0, 1, 2, 3 like that. Cos power 0. The next term, cos power 1 I have to put 2 into 1, 2. Cos power 2 into 2, 4. Cos power 2 into 3, 6. And it goes on and on. What is this cos square? Write as it is. Cos power 0. Anything power 0, we write 1. Cos power 4 is cos square theta the whole square. Cos power 6, cos square theta the whole cube. So this and this I can compare. 1, some term, square, cube and so on. So in the place of x I have cos square theta. So what is the formula? 1 by 1 minus x. 1 by 1 minus x is cos square theta. We know 1 minus cos square theta. What formula we know? Sin square plus cos square is 1. So 1 minus cos square theta I will write sin square theta. Similarly, 1 minus sin square will be cos square. Here I have 1 minus cos square which is sin square. The same pattern we can write for y. When it is cos, my answer is 1 minus cos square in the denominator. When it is sin, my answer will be 1 by 1 minus sin square theta. 1 minus sin square is cos square theta. Same pattern, what would be z? 1 by 1 minus square of the two terms, cos square theta, sin square theta. Now, we need to add x plus y plus z. When I am adding, these terms are simple for us. 1 by sin square and 1 by cos square. Let us add and check. I can cross multiply. Cos square theta, sin square theta by sin square into cos square. And we know cos square plus sin square is 1. So, x plus y reduces to 1 by sin square theta cos square theta. Write the third term. Now, I need to add these two. LCM sin square cos square 1 minus cos square into sin square. Numerator cross multiply. This term will go here. This term will come here. Again, plus sin square cos square minus sin square cos square gets cancelled. We are left with 1 in the numerator. Denominator, 3 terms are there. So how can I write it? 1 by sin square into 1 by cos square into 1 by 1 minus cos square sin square. 1 by sin square is nothing but x. We have done here. 1 by cos square is nothing but y. And 1 by 1 minus cos square sin square is z. So, we started with x plus y plus z and ended with x into y into z, and that is the problem. Exercise 4.1, question number 8. If tan square theta equals 1 minus k square, show that secant theta plus tan cube theta into cosecant theta is 2 minus k square the whole power 3 by 2. Find the values of k for which the result holds. To prove this answer, check what is given. Tan square theta is given. So, tan square theta to secant square. How to convert? Add 1 on both the sides. So, we get 1 plus tan square, 1 plus 1 minus k square. 1 plus tan square, we know secant square theta, which is 2 minus k square. Let this result be there. What is asked? Let us start with LHS. Secant can be written as 1 by cos. Tan cube can be written as sin cube by cos cubed. Cosecant can be written as 1 by sin theta. 1 sin and 1 cube we can cancel. As I cancel, it becomes sin square theta. Taking LCM, cos and cos cube. LCM is cos cube. So cos is here, cos square extra. So cross multiply. Cos square theta plus sin square theta, which becomes 1 by cos cube. 1 by cos cube we rewrite as secant cube. Already we derived what is secant square theta, but I want secant cube. So from here find out what is secant. This 2 goes to the other side as whole power 1 by 2, or in other words I can say root of. Now secant cube I want to substitute. So this whole power 3. Secant cube is whole power 3. This 3 I can bring in, so it becomes 3 by 2. So that is the right hand side answer. I started with LHS. I ended with RHS. To find values of k for which the result holds. Given tan square theta is 1 minus k square. If tan square theta is positive, being a squared quantity, it is always positive. 1 minus k square is always positive, or interchanging k square minus 1 less than or equal to 0. Factorizing k plus 1, k minus 1 less than or equal to 0. Remember the inequality. Whenever it is less than, we will say k lies between minus 1 and plus 1. So the interval I get minus 1 less than or equal to k less than or equal to 1, and that is the interval for k. Question number 9. If secant theta plus tan theta equals p, find secant theta, tan theta, sin theta in terms of p. Whenever a question is given in terms of secant and tan, immediately remember the identity secant square theta minus tan square theta equals 1, which can be rewritten as secant theta plus tan theta into secant theta minus tan theta. A square minus b square is a plus b into a minus b, which is equal to 1 as in the identity. Given secant plus tan is p. So p into secant minus tan is 1. So secant theta minus tan theta equals to 1 divided by p. Now we have two equations. Here I have secant plus tan. Here I have secant minus tan. Let us add both so that plus tan minus tan will get cancelled. We are left with secant plus secant 2 secant 1 by p plus p. Taking LCM p square plus 1 by p. Bring 2 down. So very first part is over. We found out what is secant theta. As we added here, let us subtract. This is 1 and this is 2. 1 minus 2. What do we do? Change the symbol. Now secant and secant will get cancelled. Tan plus tan is 2 tan, p minus 1 by p. That is p square minus 1 by p. Again bring 2 down. So second part of the question is over. We found out tan theta in terms of p. Now that we know what is tan theta, we know what is secant theta. We need to find sin theta. How to go with? Write tan theta as sin theta by cos theta. How will you write secant theta? It is 1 by cos theta. Now I know 1 by cos theta. I know sin theta by cos theta. Divide. Sin theta by cos theta by 1 by cos theta. Divide this answer and this answer. As I divide, 2p cancels. Cos theta cancels. We are left with sin theta equals p square minus 1 by p square plus 1, and so we have found secant, tan and sin in terms of p, and that is the answer. Question number 10. If cot theta into 1 plus sin theta equals 4m and cot theta into 1 minus sin theta equals 4n, prove that m square minus n square the whole square equals mn. To get m square, let us square on both the sides. The question will give us a clue. I want m square and n square. So square both the results given in the question. Cot will become cot square. 1 plus sin theta the whole square. 4m will become 16m square. Cot square can be written as cos square by sin square. A plus b the whole square is a square plus b square plus 2ab. The second result, cot theta into 1 minus sin theta is 4n. Squaring cot square theta 1 minus sin theta the whole square. 4n squaring gives us 16n square. Cot can be written as cos by sin. This is a minus b the whole square. A square plus b square minus 2ab equals to 16n square. Once I reach these two steps, go back to the question. I want m square minus n square. So subtract 16m square minus 16n square. Just copy both. We are subtracting. What are all common? Cos square by sin square common. Write this as it is. Minus symbol tells me change the symbol. Minus 1 minus sin square plus 2 sin theta. What all gets cancelled? 1 cancels. Sin square also cancels. 2 sin plus 2 sin is 4 sin theta. In the LHS, we have 16 common into m square minus n square. You can cancel this 4 with 16 4 times. Now bring 4 down, and that is m square minus n square. The question is m square minus n square the whole square. Square and write, mark it as 1, that is LHS. Now we proceed on to RHS. What is RHS? M into n. What is m and n? From the question, we have just copied. M if I want, bring 4 down. Similarly, n if I want, bring 4 down. So as we multiply, it is denominator 4 into 4 will give me 16. Numerator, cot into cot is cot square. 1 plus sin into 1 minus sin. It is a plus b into a minus b. So a square minus b square. How will you write 1 minus sin square? That will become cos square. Cot square we write cos square by sin square. So together cos square into cos square is cos power 4 theta by 16 sin square theta. We just compare 1 and 2. LHS and RHS are equal, take and write the answer. M square minus N square the whole square equals Mn is proved. Question number 11. If cosecant theta minus sin theta is a cube, secant theta minus cos theta is b cube, prove that a square b square into a square plus b square equals to 1. A square b square. So from the given question, let us find out what is a and b, and then we'll find out a square and b square so that we can substitute in this. What is a from here? Before that, let us simplify the LHS. Cosecant can be written as 1 by sin theta minus sin theta. So a cube we just retain. Taking LCM, 1 minus sin square theta by sin theta. 1 minus sin square is cos square theta. What is a? This 3 will come to the other side as 1 by 3. But I want a square in the question. So squaring 1 by 3 will be kept as it is. Inside the bracket let us square. So 2 will become 4. Down I have sin square theta. Now take the power in. It is 4 by 3 in the numerator, 2 by 3 in the denominator. Similarly, I can proceed. Secant is 1 by cos. LCM cos theta. 1 minus cos into cos, cos square. 1 minus cos square is sin square. B cube is this answer. B, if I want the power 3 comes to the other side as 1 by 3 power. Squaring. 2 will become 4. Cos will become cos square. When I bring the power in, it is 4 by 3 in the numerator, 2 by 3 in the denominator. Let us find out a square plus b square. As I find out a square plus b square, LCM is the denominator, sin power 2 by 3 theta into cos power 2 by 3 theta. Cross multiplying cos power 4 by 3 power 2 by 3. When I cross multiply cos into cos, add the powers. Similarly, sin into sin, add the powers. 4 by 3 plus 2 by 3, 6 by 3, that is 2. So this reduces to cos square theta and this reduces to sin square theta. The denominator we retain as it is. Cos square plus sin square is 1. So I get a square plus b square is 1 by sin power 2 by 3 theta into cos power 2 by 3 theta. Proceed on to a square into b square. As I find out a square into b square, both up and down I have cos. Cos power, subtract the powers. 4 by 3 minus 2 by 3. Similarly, sin and sin. Up and down, let me subtract the powers. So I get sin power 4 by 3 minus 2 by 3 theta. The next step, a square into b square gives us cos power 2 by 3 theta into sin power 2 by 3 theta. When I multiply, here I have cos power 2 by 3 and sin power 2 by 3 in the numerator. In a square plus b square, we have it in the denominator. When I multiply, they get cancelled and my answer is 1. So multiplying 1 and 2 gives us the result a square b square into a square plus b square equals to 1. Question number 12. Eliminate theta from A secant theta minus C tan theta equals B and B secant theta plus D tan theta equals C. One method of eliminating, we can cross multiply this by B and this by A, find out what is secant tan And then remember the formula secant square minus tan square is 1. Another way, we can use cross multiplication method to find out what is secant and tan. Solving, we use this formula when two equations are given with variables x and y. X by b1c2 minus b2c1, y by c1a2 minus a1c2, 1 by, hide the last column, a1b2 minus a2b1. So we are going to use it here. Two equations, instead of x and y, I have secant and tan theta. How will I write it? X, here I have secant theta divided by b1c2 b2c1. Multiply this. Minus c into minus c square minus d into minus b. Already one minus, here one minus, together bd equals tan theta divided by minus b into b minus b square minus a into minus c. So plus ac equals 1 by, hide the last column, AD plus BC. AD plus BC. The next step. Secant theta equals cross multiply. We combine these two. C square plus BD by AD plus BC. Same way. Tan theta equal to cross multiply. Minus b square plus ac by ad plus bc. You can try any method to find secant and tan. The next step, we remember the identity secant square theta minus tan square theta equal to 1. Secant square, c square plus bd by ad plus bc the whole square minus b square plus ac by ad plus bc the whole square equal to 1. Taking LCM, it is the same in the denominator. What is the denominator? AD plus BC the whole square. What is the numerator? BD plus C square the whole square minus AC minus B square the whole square equal to 1. Cross multiplying, we get the result BD plus C square the whole square minus AC minus B square the whole square equals to, cross multiplying, AD plus BC the whole square, and that is the result. The question is to eliminate theta. In my final answer, theta mustn't come. So we have a relation between A, B, C, D, and that is the answer.